Hi everyone, it's Andrzej Krzywda. This is my video about a little bit of analysis. And one idea that I want to introduce, or at least try out, is the idea to turn this design of objects. Let's look at this this way. So we have this just facade class tennis game 1, but the actual implementation is happening here. So we have those classes here. And while this works, I'm still not fully happy. This is, as I explained in one of the previous videos, I see refactoring, so the process of refactoring as a process of improving the code sometimes, very often, but actually it's more about learning the code. Because even if this was the code written by you some time ago, you never have the same context when you work on this code after some time than as compared to when you were working on this, when you were creating this. So it doesn't matter if this code was created by me or by someone else, whether it's legacy or not. By refactoring, I'm learning the code. So now I have a little bit better understanding, I think, what are the needs here. And now I see that actually what is happening here is that we how to call it? We seem to have a game as a state machine. That's what I see here. So the game can be in several states, probably. It's very vague for now. So I'm in the analysis mode. I'm not sure exactly. So right now you can see win rule, draw rule, ongoing, win rule, advantage rule, draw rule. So 3 rules. And there's draw result, ongoing result, advantage result. So this code is telling me that there are some states. Now, what exactly are the states? I'm not sure. Probably win, draw, advantage, and ongoing. Maybe the namings are still something to improve later on, but the concept of state machines and transitions is probably there. Now, this is a bigger thing. If I want to try out how to make it a state machine, it would probably involve many steps of refactoring, or the another attempt is to actually try and implement this code, like re-implement it again. And I can rely on the fact that tennis game 1, which is a weird class name, it's actually, this is the only actual object in our system. So somewhere, some other parts of the system probably call tennis game 1, and they keep hitting 1 point, and then they ask for the score. So from the perspective of the other parts of the system, obviously it's artificial here, but we can imagine this. Only tennis game is actual, what I would call an object. Obviously we have some other objects in there, in between, like those player, arbiter, advantages, but I would say there are objects, but at the lower level. From the architecture perspective, this is the only object. So as long as I have the same API and the result will be the same, I can try to re-implement this unit, this object. But before I can start working on this, I need to make sure, I need to be very confident in my tests. So those tests, they seem to be very good actually. So I now understand what are the possible results. So it's actually grouped by the possible result types. So those are all draws. Those are the all possible situations where there's something 2-0. Then there are, I think, all the combinations in here where there is somewhere in between, like not 0, but still not win. Sometimes it's winning, but not advantage specifically. Then we are testing all possible advantage, but well, not all, but some crazy ones and some normal ones. And we are testing the some other cases here. So this is a good coverage for the final score expectation. But if I want to change my object into a state machine where there will be state transition, I need to make sure that the possible state transitions are also covered. And this piece of code, this is actually a weird implementation. So we need to be very careful when tests are very smart or too smart. So what is happening here is that there's, for some reason, there's tennis game class, but now for whatever is the, like here, so we call play game, and then we grab the things exactly as they are in this thing here when this argument is actually score and this is the expectation. And the way we get to the final score is by hitting, by initializing the game and then hitting game 1 point or 1 point. And the algorithm here is that whenever we iterate from 0 to the maximum of P1 points, and then if P1 is still not there, we're increasing this, and then we are checking P2, and if we are not there, then we get there. The interesting point, and it was really hard for me to spot actually, I just realized it just before recording this video, that we never have a case for a situation where player 2 was leading. You see, this piece of code is always increasing P1 first and only then catch up with player 2. Which means that, for example, when there was result 1, 1, when there was result 1, 1, 1 to 1, we never get result 1 to 2 as a transition. It would always be 2 to 1. So that's an important point for me to improve those tests somehow. I'll try to cover this in this next video. But this is important that I cannot go to another implementation. So, on one hand, this kind of testing is very good because it doesn't get into the details of my object design. So where I treat my object design as whatever is below the tennis game class. So it doesn't go into details. That's great. But it's the tests are not, and for this specific implementation, those tests are perfect. I think, at least I didn't spot a problem with them yet. But if we want to change for a different kind of implementation, where, for example, the state machine will have different transitions, this might be more important overall. So the next step will be to improve the tests. And that's it for this video. In the next videos, we'll try to experiment with the state machine. And the experiment with the state machine is not going to be the final result. We just want to implement it differently and then see whether this reflects our thinking model better, whether this is something better. I'm trying not to get too used to the current implementation. Like whatever is better, I can just replace it, and probably we'll never get to the perfect implementation. It's just we can try to improve. Thank you.